Hi guys, welcome to the session. So this is about Stella application development and it's about the introduction to Stella and how you can build Stella based applications. So let's start. What is Stella? So Stella is ideally a blockchain that is more popular out there, mainly for bank transactions and asset transfers using blockchain. So it's ideally founded by Jet McCleb. So he is the serial entrepreneur in the blockchain. So he is the one founded famous chain called Ripple. So this is his second invention as the Stella one in the blockchain industry. So Stella is like as mentioned is blockchain is using their own currency. So Stella is using their own currency as a native currency called XLM. It's called as XLM or Lumens in the blockchain community. So what is Stella? So Stella is as I mentioned it's a platform that connects banks, payment systems, and it will be integrate money as well as reliable assets for like transferring for no cost. So that is one of the advantages in Stella, and it's make transactions more fast, like 3 to 5 seconds, comparing to other blockchains like Ethereum or Bitcoin that takes around more than 7 to 10 minutes. So why, if you all have now a question like why Stella is more fast and very consuming very less transaction fee compared to other blockchains, because Stella is a mining free chain. So what is meaning by mining free is before that you need to know like what is mining. So mining is as mentioned in previous, like mining is a game kind of a theory. So multiple computers and multiple nodes will be compete together to find a final block or the final ledger of the blockchain. So for that they will spend so much of computation power and energy. For that it will be take so much of time for them to create these blocks, as well as it will be take they spending so much of energy means so much of computation power means so much of electricity. So for that we need to reward them as well, otherwise there will be no one going to do this process just because they're going to mine these things. So we need to give some mining rewards as well. So that's why Bitcoin and Ethereum is consuming more time to create these transactions as well as getting more transaction fees. But there are different processes as well. So one of the things Ethereum and Bitcoin is using is proof of work. So that's what I mentioned was there. But there will be other applications like other consensus algorithms like proof of stake. So in proof of stake mechanism, what happens is people can come and they can lock their monies inside a locker kind of a thing. So who is the one locking more money will be automatically selected as a miner, and there's no kind of a game theory. Multiple people will compete together to create these blocks, but multiple people will compete to put the money inside the locker, and once they lock it, the person who locked more money will be selected as a person as a final person to do the mining work. And why he is selecting is because he locked more money. So that means that people will have the more trust on him to do the good job. But if he do a bad job and if he done some bad things in the mining process, he'll be lose his a percentage of the stake, and he'll be get the return money back as he'll be lose something. But if he done a good job, he'll be get the whole money that he locked out of the out of the wallet, as well as he'll be get some incentives as well. So the another famous algorithm is kind of a Bayesian and fault tolerance one, but we cannot call that as a decentralized one because it's running on top of appointed authorities or entities. So we need to provide centralized parties or centralized organizations. So a couple of organizations can come together and decide whether the transaction is valid or not, and comes to agreement to create the blocks. And Stale is using their own consensus protocol called Stale Consensus Protocol or SCP, and it's ideally comes from a federated Bayesian agreement. So as you can see in the images, it's have like a couple of slices or a couple of circles. So each slices will have contain a amount of nodes. So for example, if you take that 10 nodes inside one circle or one slice, each 10 nodes will be talk to them and they will come to agreement whether they can create this transaction is a valid or invalid one. So once they come to agreement, each nodes in that slice will be a part of the another slice as well. So they will be passed this information from one slice to another slice using these peer-to-peer connections. So as you can see in the image, there will be two slices overlap together because each node will be belongs to a couple of two or more slices. So that's how the transaction will be passed, and that's why it's consuming less energy and less time to create this transaction. Ideally, still are getting only 3 to 5 seconds to approve these transactions. And there's another question like people will have like if you're new to blockchain, why you need ideally mining? So what is the reason that you need mining is if you take it as a normal scenario for a bank or something, if you run out of a cash, what the government is doing is they will go to the central bank and print those monies. And if you take this another scenario, if you go to the bank and making these payments, the bank will be do the validations about the account, whether you have the money or not, whether the receiving person has the account or not. So all these validation will be done by a central party. But in the blockchain, we don't have any central authorities or any hierarchies. So we goes everything. centralized and decentralized process, so it's very difficult for a person to go and do the mining process or go and do the validation process. So for that we are using the mining thing. So once we're using this mining, what happens is if we use a proof of mining for a Bitcoin scenario. So if you use a mining process for like a Bitcoin scenario, what happens is in the Bitcoin and Ethereum scenario, when you use proof of work, this mining process will be you do this validation on behalf of the other nodes. So it's in a decentralized process, so anyone can participate in the mining, and there's no restriction for any people to participate or not participate. So they will be do these validations as a decentralized authority and perform these transactions and create these blocks, as well as if you take it as a central bank scenario, when they run out of money, they'll be go and print these hashes. But it is the decentralized one, so there's no person to create these new coins. So how the new coins will be created is, they in Bitcoin scenario they use mining, and as a rewards they will put the new coins. So when there's a person who done the mining and they created a block, they will get some money as a rewards. But in Stellar scenario, as mentioned, there's no mining goes there. So how they get the money is, initially when the Stellar was created, they given 100 million lumens. So after 100 million lumens, due to the loss of lumens, because there will be lumens that people will dump it, or there will be lumens that will stuck in the unlocked accounts, and due to the economic growth, so there will be more accounts created nowadays, and there will be more people join there. So for that, what Stellar is doing is they perform a kind of inflation, and they'll be give weekly rewards as 1% annual rate for each week. So 1% annual rate, and they divide it into each weeks, and each week people can get some generated coins as the new coins comes into the market, and that will be distributed through the community based on the amounts that you have in the stake. So that is why we need mining, and that is why compared to these other consensus algorithms, that is why stable consensus is more fast and more profitable than the proof of work or proof of stake. So if we take into the state architecture ideally combined into two sections, so two components, Stata core and the horizon. So Stata core, if you are running a node in Stata, you ideally need a Stata core and the horizon to work it properly. But if you are only doing for a Stata consensus and validation process, you can only use Stata core. But if you want only application API calls and retrieving the information, you can only use horizon. But the two things combined together as called as one of the nodes, and each cores will be connected to other cores as a decentralized one, as same as how the other blockchains works. So if we take it into stable architecture more depth as what we see now, so you can have multiple applications like mobile applications or online banking APIs or even a web applications. So all the applications will be make a call through horizon, and the call will be like from horizon will be make a call to Stata core. So once we get the call to Stata core has a DB and a ledger, so they will be made together and sync together, and they'll be produce the output what we want. And if we want to make some insertions as a new transactions or new data insertion, that will be go into horizon and go into the Stela, and it will be recorded. And once it is recorded in one of the Stela, it will be Stela core. It will be like decentralized. It will be peer-to-peer, passed to other nodes as well. So that's how the data is distributed and decentralized together for the other nodes. And as I mentioned, insertion and retrieval, may you have a question like, what about it's acting as a database or not? So it's not acting as a database, because in the database we can perform update and deletions as well, but in any of the blockchains we cannot perform updates and deletes, because it's a immutable ledger, so we can only insert and we can only retrieve it. So as I mentioned, Stela is using a ledger as well as a DB. So DB is ideally it's like synced together, so we cannot put something in the DB and we cannot delete something that is already in the ledger. So it will be shows that something is deleted from the DB. So it's performing in a high secure way, so we cannot tamper any of the data informations. But this DB is mainly needed for to make the transitions comes out. So when you're calling things, it will be easy for to us to get it from the SQL DB than getting from the Stela ledger. But still, the accounts are like, and the data are validated and authenticated by blockchain itself. So if you take the Stellar ledger, if you look into more much into Stellar ledgers and its characteristics, one of the thing is the Genesis ledger. So any of the blockchains, we create a first block, we call it as Genesis. In Stellar, we don't call it as blocks, so we call it as ledgers. So we call the first ledger as Genesis one. And the time, as I mentioned, it's only 3 to 5 seconds. So each 5 seconds the ledger will be closed, and there will be a new ledger will be open. And the another important thing is the sequence numbers. So each account will be tied with one sequence number. Ideally, each transaction will be tied with one sequence number. So once you make a transitions in a, this is mainly for double spending, reducing the double spending issues. So if you make two transitions in the same sequence number, that cannot be possible in Stela. So ideally one can be coincide and the second one need to be one upper than that transition. So we cannot do the double spending issues in Stela. And the second thing is you cannot jump the sequences. So something like if you have a sequence around 11, so the next sequence is ideally need to be 12. So you cannot jump from 11 to the next transition 13. It's not possible. So to maintain it, you need to be go order by order, or if you want to jump it, you can use blockchain to jump that transition, that we can use it as a bump sequence. So I'll explain that one in the demo. And the next one is a backward link. So it's same as how the blockchain links together as a blocks, as a backward link to remembering the previous transition hashes, previous block hashes, same as it will be remember the previous ledger hash. And another advantage in Stela is mainly for the assets. So you can create any amount of assets in within seconds, within minutes in the Stela. So it's very easy to do it. And you can transfer assets. They maintain a separate ledger for each assets, and it's kind of an order book. And order books will have the sell orders and buy orders, so it will be automatically matched together. And it's an on-chain order book in Stela, so that is unique than many of the other blockchains out there. And you can create any amount of assets like USD or SDR or even a euros, and you can easily trade with other people. And in the right side image shows as you can see there's a person transferring the trading assets like fish and the meat. So this is similar like what happens in the ancient times. There's no money, but people has the two valuable assets and they trade between them for based on the assets. So similar like that nowadays, like Stela is using, like there's no need to be a money, but you can create the assets in the blockchain and you can trade the assets. So you can sell milk and buy the apples on the blockchain using Stela as asset trading stuff. So if you comes to the Stela, and if we're talking about blockchain, we need to ideally talk about smart contracts as well. So if you're talking about Stela smart contract, it's not as flexible as what out there in the Ethereum or Hyperledger. So what is the difference is like Stela is, we cannot write our own logics in Stela as a smart contract, but still we can use they have the set of operations, so we can use the operations and we can play around with that, and we can build a high secure smart contract that are using especially multi-signatures features and sequence. We can build a proper smart contract that can handle any amount of money transactions or some sort of data transactions. So if you take it into the Stela operations, there will be operations like create account, payments, and these are the main operations of Stela, and you can play around with these to make a smart contracts. So payment account is like ideally the money transactions, and if you go to the path payment, it's ideally transactions from one place to another place. So ideally euro, if you want to transfer euro to sterling pound, so you can transfer euro to USD and USD to sterling pound. So you can go different paths to convert the assets. And you have offers, as I mentioned, you can trade different assets. And you have inflations and managed data, that is the operation that we use to store the data inside the blockchain. And we have the bump sequence and stuff as well, so we'll go more deep into them during the demo. So let's start with our demo. So this demo is ideally divided into two sections. So one, we are going to show about how you can do the things in Stela laboratory, and the second one is we can show about how you can do things in the code repo as well. So we can go to Stela, and this is the Stela laboratory. So this is kind of a place that you can go and play around with easily without making any code, so without writing any code, much codes into Stela. And you can see there will be networks like test, public, and custom. So these are the ones, as I mentioned, if you're using a public network, you need to make, when you're making transaction, you need to pay some fee as well. So if you're making if you're trying with public accounts, you need to buy the actual XLMs for the real money, and you can make those transactions. But for testing purposes and learning purposes, they use a test network as well. So you can create a fake XLM Lumens and you can play around with it. It's ideally kind of a test coins. So once you click the generate key pair, it will create a new account. So each account will have a public and a private key or secret key. So public key is ideally the identity of that account, and the secret key, it's more like a password. So it's need to be kept in a secure way. So if you release this secret key to any person, they can easily kind of controlling 100% control of your account. So you need to keep it in a secure way than releasing to any other person. So you can we can just copy this public key, and to play around with the Stela laboratory, we need some test lumens. So we can go and get some test lumens out there using a friend bot that is inbuilt by the Stela laboratory. So ideally we need two of the accounts to make these transitions possible. So we can then go to the Stela Explorer. So once we go to the Explorer, we can ideally see what's going with our accounts and how it works there. So as we founded the account, so it's ideally get around 1 lakh Lumens initially. So you can see it like 1 lakh Lumens, and it's mentioned as the currency is native. So if you're using a unique assets like Fish or Apple or whatever things, so that will not come as a native assets. So this is only for the native assets, and now we can easily go and make a transition. So this is the one I mentioned is a sequence one. So this sequence is ending with 57. So if we perform this transition, so the next transition when we make, we need to make the sequence as 58. So if we make now as a sequence is 58, the transition will be failed because it goes only a sequence order. So we can go and click the payment, and we can get the second account, and we can set the amount as for example we can set it to 100. And here we need to put the signatures as well. So once you put the signatures on it, the transaction will be authenticated, and it will be verified by the person that who is sending, because this is like more personal to the person. So it will be knows that this person signed this one and send it as a valid transaction. So once we submit the transaction, it will be goes to blockchain, and it's take around 3 to 5 seconds. If you're comparing Ethereum, it's take around 7 to 15, and if you go to Bitcoin, it's take more than 30 minutes. So now we made the transition, so we can go and check how the transition, we can retrieve the transition ideally from blockchain to check it whether it's how it comes. So you can see like this is the sending account, so we made this from this account. So you can see the GFI is the from, and this is the to account, and this is the amount that we transferred, and it also shows that the timestamp, and it's also shows the timestamp and other things. Just one sec. So it shows the timestamp and other informations as well, and also you can see the ledger where it's gone and stored all the things. So this is one of the way of making the transition. So we can make a transition in another way that comes as a multi-signature one. So that is like kind of a check that need to be signed by two people. So that is the multi-signature one. So we'll show it how it goes. So we'll go to the builder, and we'll be, so once it's previously it's 57, so once we increase the sequence it goes to 58. So we can go to the payment, and we can again transfer to the same account, but to make it more secure, like to multi-signature one, so we need another kind of account. So we can create a new account, and we can fund that one as well. So previously we made the transition from 1 to 1, so now we are going to make the transition that is ideally signed by two people. So once we fund it successfully, so we can go and we can make the same transition, but in a way that we'll be put this account. So ideally this public key and this public key need to be signed, ideally two entities need to sign to make this transition successful. So to check it like whether it's working properly or not, so we can put one signature and we can submit it. So ideally it will be get failed. So you can see like it's saying as it's a bad authentication. So because we need two people to sign it, so we only sign using one person, so we can go and sign using another account as well. So to do it, as we can do it through here as well, or else in the real case scenario what we will be doing is we will be submitting this one, and before submitting it, like we will be get this as a kind of a information that we call as XTR in Stellar terms. So it's kind of envelope, but you cannot change anything in these details, because this is ideally the envelope contain all the transaction information and you sign that one against. So once you change the simple letters or characters from here, this will be failed because it will be not matching with the exact signature that you put. So we can go and easily view these transitions from XTR viewer. So once we go to the XTR viewer, it will show like what are the informations about the amount, asset, and what is the public key and the private key as well. So from and to, and it will be show like what is the secret key it's already signed and what is the secret key it's going to be signed. So ideally it's not revealed the secret keys, but it shows the hint of the public key. So using this public key, we can, if we know the private key, so we can sign it, so it's not revealed to other people. So we can put it as we already signed using one account, so we can simply go and sign using the second account. So once we sign only using two accounts, the transaction will be get success and it will be goes validated. So same as what we done for the first account, first transaction. So we can go and see how much amount goes and the timestamp and all those things. And if you want, like, as we send it from this account, we can go and see what is the amount either deducted or not from there. So ideally we made 200 100 rupees transaction, so it's deducted from here as a 900. So it's ideally one is gone as a single transaction and other one is gone as a multi-signature transaction. So the single transaction initially that we made will be deducted from here, and the multi-signature transaction that we made will be ideally deducted from here, because that's the one we used as the source accounts. So once we made this transaction, you can see like it's deducted this 100 rupees amount from there, and it shows the keys, and this is the other information that you can get from the transaction details informations and account details informations. So you can, if you get time, you can go and check around. You can easily play around because there's not much effort that you need to make it to build the codes and things. So one of the another thing we can show it like how we can use this data to store the data. So one of the way we used to store it, like we can again each of the transaction we need the sequence. So the way we store the data is we use the manage data operation. So it's like a key value storage. So we need to use a key as can use the key as hello, and can go as blockchain. So it's normally store these informations in a base64 manner, so it's not readable for all the people, but you can get it and convert it from base64 and read it. So once we submit it, we can go to the transaction and again view it, like how the data is stored there. So once we go, it show the name as hello and the value as in a base64 format. So we can get this, copy this one, and you can convert it into a base64, so it will comes as blockchain. And also, like as I'm doing these things, we will get these transaction hashes. So if you want, you can just get this transaction hash, and you can by yourself you can go to the Stellar laboratory and check these transactions, because this is open and a public ledger, so anyone can read and anyone can write these things if you have a proper account and valid authentications. And you can make another thing, as I was mentioned, you can do the multi-signature transaction as well as you can do a multi-signature account. So it's kind of a joint account. It will act as a joint account. So you can take this as account. So it's ideally the first one. So we can take it and we can use set options, and initially the master weight is 1, it's already there, so we can put it as again master weight as 1, and we can make the threshold weights as 2. So once we make this threshold weights as 2, and we can select the signer. So ideally the signer is a public key, and we can make the signer weight as again as a 1 as well. So once we make this as a 1, so you can see this low threshold, so it's at 2. So this low threshold is ideally the ones that they categorize the operation. So if you have low threshold, you can perform some sort of transactions. If you have medium threshold, you have perform another level of transaction, and if you have high threshold, you can perform a different level of transaction, like changing the set options and stuff. So once we get this one, you can see like we set the master weight to 1, and master weight of the signer also to 1, and other things as 2. So ideally what it means is like to make any transaction from this account, ideally this account cannot make it because it has only master weight 1. So we need both these accounts to come together to make any transactions. So once we put that master weight as 1, we need to ideally mention the master weight key as well. So for that we can go and copy the second account as the key. So once you mention this as a second signer key as a joint account kind of stuff, and can go and sign it. So once it was get success, it's now changed to a joint account kind of a stuff. So if you want to go and create any transaction, simply as how we store the data, if it goes with so if you perform now, it will be get failed because it's only signed by one authorized signer, but it's ideally needed 2 parties to sign it. So it's get a transaction bad. So you can go back and you can put both these signatures. So either one of the accounts cannot perform anything, but both these signers need to be signed together to make this transaction success. So once these 2 accounts sign, it will be get as a success one, and you can go and view these transitions. So this is the one demo that we plan to do it through Stellar Laboratory for this webinar, and you can check maybe you can show something like how you can do these things in the code base. So in the code base, it's still have different SDKs. Like we are using Go SDK because Go is the language that mostly used in the blockchain community, and it's more feasible and efficient for blockchain related applications and ideally the dApps. So if it goes as a Stela, they have Go SDKs, they have JS SDKs, they have Java SDKs. So even you have C++. So if you have family with whatever language you are familiar with, you can download the SDKs and you can easily play around using the code bases. So as you can see here, we mentioned the source and the destination. So source, we mentioned the private key because it's the one that we are sending. So we know our private keys, and destination is goes as a public key. So it's the one who is receiving it. So we can ideally sending 10 transitions. So we already set up the key, so I'm not going to set it again. So you can just go and use the command to run it. So once we run, it will be take around 3 to 5 seconds to go to the Stela and get validated. So once it's get validated, we can ideally retrieve these informations like the response as a ledger hash and all. So now we got the information as this the hash that got success, and this is the ledger that we stored. So to make it sure, like we can go to the laboratory, sorry, we can go to the Explorer and check it how the transition was comes out. So it shows like we send the 10 amounts, and this is the public and the private key. So this is the public key from account and the public key from the two account that received. So you can see all of these informations together. So